It is not legal to use aluminum wires from your meter to your indoor panel in Florida. The Florida Building Code, which is based on the International Residential Code, prohibits the use of aluminum wiring for branch circuits in new construction. This includes the wiring from the meter to the indoor panel. The Florida Building Code specifically states that aluminum branch circuit wiring shall not be installed in new construction, according to Florida Building Code, Section R314.15a. This prohibition is due to the safety concerns associated with aluminum wiring. Aluminum is a lightweight and inexpensive metal, but it is also more brittle and prone to corrosion than copper. This can lead to loose connections, arcing, and potential fires. In addition to the Florida Building Code, many local municipalities in Florida have also adopted ordinances that prohibit the use of aluminum wiring in new construction. Therefore, it is important to check with your local building department before using aluminum wiring for any electrical work. The primary reasons for prohibiting aluminum wiring in branch circuits are centered around safety and reliability. Firstly, aluminum has a higher coefficient of thermal expansion compared to copper. This means that aluminum expands and contracts more than copper with changes in temperature. Over time, this can lead to loosening of connections at terminals and devices. Loose connections increase electrical resistance, which generates heat. This heat can then cause oxidation and corrosion of the aluminum wire and the terminal, further exacerbating the problem. The cycle of loosening, heating, and corrosion can ultimately lead to arcing and electrical fires. Secondly, aluminum is more susceptible to corrosion than copper, especially in the presence of moisture and certain chemicals. Corrosion increases the resistance of the wire, which, as mentioned before, leads to heat generation and potential fire hazards. In older installations with aluminum wiring, a common problem is the use of improper connectors and terminals. Aluminum requires specific connectors designed for aluminum wiring. These connectors are typically made of aluminum or are specially coated to prevent galvanic corrosion between the aluminum wire and the connector material. The use of copper connectors with aluminum wire can lead to rapid corrosion due to galvanic action, which is an electrochemical process that accelerates corrosion when two dissimilar metals are in contact in the presence of an electrolyte, such as moisture. Thirdly, aluminum is a softer metal than copper, making it more prone to damage during installation and maintenance. Nicks, scratches, or over-tightening of connections can damage the aluminum wire, reducing its current carrying capacity and increasing the risk of overheating. The Florida Building Code references the National Electrical Code, commonly known as the NEC, which provides detailed requirements for electrical installations. While the Florida Building Code may have specific amendments or additions, the NEC serves as the foundational standard for safe electrical practices. It is crucial to understand the relevant sections of the NEC related to wiring methods, conductor types, and overcurrent protection. When dealing with electrical installations, it is essential to consult the latest edition of the NEC and any applicable local amendments. The NEC provides tables and guidelines for determining the appropriate wire size for a given load based on factors such as ampacity, voltage drop, and environmental conditions. It also specifies the types of wiring methods allowed for different applications, such as residential, commercial, and industrial. When upgrading or replacing electrical wiring, it is important to use the correct type of wire and follow all applicable codes and standards. For branch circuits, copper wire is generally the preferred choice due to its superior conductivity, corrosion resistance, and reliability. If aluminum wiring is present in an existing installation, it is recommended to have it inspected by a qualified electrician. The electrician can assess the condition of the wiring, connections, and devices, and recommend appropriate repairs or upgrades. Possible solutions for dealing with existing aluminum wiring include replacing the aluminum wiring with copper wiring, using approved methods for connecting aluminum wiring to devices, and installing arc fault circuit interrupters, also known as FSIs, to provide enhanced protection against electrical fires. The cost of replacing aluminum wiring with copper wiring can vary depending on the size and complexity of the installation. However, it is generally considered a worthwhile investment in terms of safety and long-term reliability. When connecting aluminum wiring to devices, it is essential to use connectors that are specifically designed and listed for use with aluminum wire. These connectors are typically made of aluminum or are specially coated to prevent corrosion. They also provide a secure and reliable connection that can withstand the effects of thermal expansion and contraction. Arc fault circuit interrupters are devices that detect arc faults, which are dangerous electrical conditions that can lead to fires. ASIs are designed to trip the circuit breaker when an arc fault is detected, interrupting the flow of electricity and preventing a fire from starting. The NEC requires ASIs to be installed in many areas of the home, including bedrooms, living rooms, and dining rooms. In addition to following the code requirements, it is also important to follow good electrical practices. This includes properly sizing the conductors for the load, using the correct type of connectors and devices, and making sure that all connections are tight and secure. Regular inspections of the electrical system can help to identify potential problems before they become serious hazards. Look for signs of loose connections, damaged wiring, or overheating devices. If you notice any of these problems, have them repaired by a qualified electrician as soon as possible. When working on electrical systems, always disconnect the power at the main breaker before starting any work. Use insulated tools and wear appropriate safety gear, such as rubber gloves and safety glasses. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician to do the work. The use of aluminum wiring in electrical systems has a history of both acceptance and controversy. In the 1960s and 1970s, due to rising copper prices, aluminum wiring became a more prevalent alternative for branch circuit wiring in residential construction. However, problems soon emerged, primarily related to improper installation techniques, incompatible connectors, and the inherent properties of aluminum. These issues led to overheating, loose connections, and an increased risk of fires, resulting in the restrictions and prohibitions we see today in codes like the Florida Building Code. The problems associated with aluminum wiring are not necessarily inherent to the material itself, but rather stem from the ways it interacts with other materials in the environment and how it is installed. Aluminum has a higher coefficient of thermal expansion than copper, meaning it expands and contracts more with temperature changes. This can cause connections to loosen over time, leading to increased resistance and heat buildup. Aluminum also forms an oxide layer on its surface when exposed to air, which is insulative and can further increase resistance at connections if not properly addressed. Furthermore, galvanic corrosion can occur when aluminum is in contact with dissimilar metals, such as copper, in the presence of an electrolyte like moisture. This corrosion can degrade the connection and increase resistance. To mitigate these issues, special connectors and installation techniques are required when using aluminum wiring. These include the use of antioxidant compounds to prevent oxidation, connectors specifically designed and listed for use with aluminum wiring, and proper tightening torque to ensure a secure connection. Despite the challenges associated with aluminum wiring, it is still used in certain applications, such as for service entrance conductors and feeders, where larger conductors are required and the cost savings of aluminum can be significant. However, in these applications, the connections are typically made with larger, more robust connectors and are subject to more stringent inspection requirements. When dealing with existing aluminum wiring, it is important to understand the potential risks and take appropriate steps to mitigate them. A qualified electrician can perform an inspection to assess the condition of the wiring and connections and recommend appropriate solutions. One option is to replace the aluminum wiring with copper wiring, which is generally considered the safest and most reliable solution. However, this can be a costly and disruptive process. Another option is to use approved methods for connecting aluminum wiring to devices, such as the use of coupling connectors, which are crimp connectors that are specifically designed for joining aluminum and copper wires. These connectors create a permanent, gas-tight connection that prevents oxidation and corrosion. A third option is to install arc fault circuit interrupters, or ASIs, which can detect arc faults caused by loose connections or damaged wiring and trip the circuit breaker to prevent a fire. ASIs are now required by the NEC in many areas of the home and can provide an added layer of protection against electrical fires. It's also crucial to ensure that all connections are properly tightened and that antioxidant compounds are used to prevent oxidation. Regular inspections can help identify any potential problems before they become serious hazards. The Florida Building Code's prohibition of aluminum branch circuit wiring in new construction reflects a cautious approach to electrical safety based on the historical issues and potential risks associated with aluminum wiring. While aluminum wiring can be used safely in certain applications with proper installation techniques and materials, the potential for problems, especially in residential branch circuits, has led to the preference for copper wiring in new construction. When considering any electrical work, it is always best to consult with a qualified electrician who can assess the specific situation, provide expert advice, and ensure that all work is performed in accordance with applicable codes and standards. Attempting to perform electrical work without proper knowledge and training can be dangerous and can lead to serious injury or property damage. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Electrical codes and regulations can vary depending on the location, so it is always important to check with the local building department for specific requirements. The use of aluminum wiring in older homes presents unique challenges and considerations. While replacing the wiring entirely with copper is often recommended for optimal safety and reliability, it can be a significant undertaking in terms of cost and disruption. Therefore, alternative solutions are often explored, such as pigtailing, which involves connecting a short length of copper wire to the existing aluminum wire using a specialized connector that is designed for joining dissimilar metals. This allows for a safer connection to outlets, switches, and other devices. Another approach is to use CO/ALR rated devices, which are designed to be compatible with aluminum wiring. These devices have terminals that are made of a material that is less susceptible to corrosion when in contact with aluminum. However, it is important to note that CO/ALR rated devices are not a universal solution and may not be suitable for all applications. In some cases, the best approach may be a combination of different methods depending on the specific circumstances. For example, pigtailing may be used for some connections, while CO/ALR rated devices are used for others. It is also important to ensure that all connections are properly tightened and that an antioxidant compound is used to prevent oxidation. Regular inspections can help identify any potential problems before they become serious hazards. Regardless of the approach taken, it is crucial to have the work performed by a qualified electrician who is experienced in dealing with aluminum wiring. An electrician can assess the condition of the wiring, identify any potential problems, and recommend the most appropriate solutions. They can also ensure that the work is performed in accordance with applicable codes and standards. When working with aluminum wiring, it is essential to avoid certain common mistakes. One mistake is to use standard wire connectors that are not designed for use with aluminum wiring. These connectors can corrode over time, leading to loose connections and potential fire hazards. Another mistake is to over-tighten the connections, which can damage the aluminum wire and reduce its current carrying capacity. A third mistake is to fail to use an antioxidant compound, which can prevent oxidation and improve the reliability of the connection. It is also important to avoid mixing aluminum and copper wires in the same circuit, as this can lead to galvanic corrosion. If it is necessary to join aluminum and copper wires, a specialized connector that is designed for this purpose should be used. Aluminum wire is still used in some applications, such as for service entrance conductors and for large feeders in commercial and industrial buildings. However, in these applications, the wiring is typically installed by qualified electricians who are familiar with the proper techniques and materials. The wiring is also subject to more stringent inspection requirements. In general, the use of aluminum wiring in branch circuits is discouraged, especially in residential buildings. The risks associated with aluminum wiring outweigh the cost savings, especially when considering the potential for fire and other hazards. The Florida Building Code's prohibition of aluminum branch circuit wiring in new construction is a prudent measure that helps to ensure the safety of homes and families.